Okay. So, week 3 of online classes with coronavirus. This time we're getting more of a review type deal with our geometry stuff. So, chapter 12 review. So, the first thing we have to worry about is our first section, 12-1, which is all about those tangent lines. Okay. So again, today we're just going to review, which means we're going to do a whole bunch of practice problems type deal. Just prepare for your quiz that you'll have the following week. So, tangent lines. First, we need a circle. Remember, if I have a tangent line, that just means that to some point out here, oof, yikes. What was I thinking there? Remember, tangent line just means it only intersects the circle at one point, and it has to be perpendicular. Okay. So let's see. If AC, if this entire thing was 19, and this entire thing was 16, solve for x. Or I would be finding the radius, because again, this should be the center. I know it's off center, and we're just going to pretend. So, again, tangent just means there's a right angle, and this whole thing's a triangle. So, again, I can just use Pythagorean theorem. A squared plus b squared equals c squared, where c squared has to be my hypotenuse. In this case, it's 19 because it's opposite the right angle. So I get x squared plus 16 squared equals 19 squared. Well, 16 squared, I believe, is 256, but let's double check that. Yep, 256 x squared, and then 19 squared, I don't know off the top of my head, which is 361. Okay. Now all I have to do is subtract 256 from each side. So I get x squared is 105, square root. So x is approximately 10.2. So again, just Pythagorean theorem, right triangle, solve for it. Okay. Separate problem. Let's see. See, if I tell you that this part is 7, let's see, this part is 12, and then I have a radius of x, where I'm solving for x. Okay. And again, I will tell you that it is tangent, so this just be a right angle. Okay, this looks a lot more messy and more complicated, which technically it is, but it's still the same problem. I have a tangent, I have a right angle, and I have a triangle, so I can just use Pythagorean theorem. A squared plus b squared equals c squared. Now again, my a and b have to not be my hypotenuse, so x squared and 12 squared. 12 squared, 144. I get x squared. But the big thing is my hypotenuse is x plus 7. It's this piece and this piece for the entire thing. So that's actually x plus 7 squared. And remember, x plus 7 squared is the same thing as x plus 7 times x plus 7. Again, squared means I'm multiplying it by itself. So x times x gives me x squared. X times 7 gives me 7x. 7 times x gives me 7x. 7 times 7 gives me 49. And now here I can just combine like terms, so I get x squared plus 14x plus 49 equals x squared plus 144. Now I'm going to do some algebra to try to solve for my x. Okay, I can subtract x squared from both sides. X squared minus x squared, 0. X squared minus x squared, 0. I can subtract 49 from each side. 49 minus 49, 0. 144 minus 49. 144 minus 49. 95. So 95 equals 14x. And then I'll just divide each side by 14. So x is approximately 6.8 in this problem. So again, that one looked a little trickier, but the same process is how we got there. Is we get one leg of the triangle squared plus another leg of the triangle squared equals that hypotenuse squared. It just we had to really be a little bit more critical with what our hypotenuse was and square it. Please don't do this. Please don't say x plus 7 squared and then just square each individually where you get x squared plus 49. Because that leaves out this middle section, this 14x. That's why you have to rewrite the expression and do the actual distribution. Okay. So another thing that I could ask you is, if you're given all three values, it'll say determine if tangent. So the question is, we're asking, is this a right triangle? Now, we could develop a different method for solving that and doing those different things, but what it comes down to is we can just use the same logic we applied for if we knew it was a right triangle. We would just use the Pythagorean theorem. So to prove it's a right triangle, we could still start with our Pythagorean theorem, where the idea of a squared plus b squared, does it equal c squared? Well, if equal on both sides, then it's a right triangle. Then it has to be tangent, then tangent. So if my Pythagorean theorem works out perfectly, then I know it's a right triangle, and it's a right angle, therefore it has to be tangent. Okay. So I get 5 squared plus 12 squared, and I get 13 squared over here because, again, opposite the right angle has to be by itself. 5 squared, 25, 12 squared, 144, 25 plus 144 is 169, 13 squared is 169, 169 equals 169, so my answer would be yes, it is tangent. Moving on to 12-2. Chords and arcs. Okay, find the value of x. So this, I have, well, let's say I have a 6, I have a 6, I have perpendicular, I have 2 tick marks, and then I have a 9. So with this type of problem, remember that chords that are equidistant away from the center have the exact same value. So this entire chord is equal to this entire chord. So if this piece is just a 9, and this piece has to also be a 9, so the entire thing would be 9 plus 9, so 18. Therefore, actually the entire thing, x has to also be 18. On to 12-3, which is all about inscribed angles. Okay. Okay, let's see, I need letters, so let's see, this is my center C. So let's go with I, J, K, L. Okay. So I have a question such as, what does angle I intersect? So, the thing to notice here is that I is clearly on the perimeter, and if we were to find angle I, it would be right here, right? And what it intercepts is that opposite arc. So, you would get arc L, K, J, or arc J, K, L, depending on how you want to describe it, because LKJ is the same thing as JKL, depending on which direction you're going. Now we're going to get into a sort of the fancy algebra of it. Here we have angle angle of 60 degrees, and then we have x, which represents our entire arc. I'm just going to switch to blue just so it's easier to see. X is my entire arc. Now remember, my arc always is double my angle. So my angle is whatever half my arc is. So in this case, to arc by itself, I multiply each side by 2. So 2 times my angle equals my arc. And if my angle is 60 degrees, I get 2 times 60. So my arc, x, has to be 120 degrees. So here I have a circle with a quadrilateral, and my things are C, 120, D, and 95. I get a B, an A, and a 93. So here we're going to naturally solve for A, B, C, and D. So let's start with A, sure. So looking at my 120, we see that my 120 captures this entire arc. So, remember my 2 times my angle equals my arc, right? So if I get 2 times 120, that's going to equal the entire arc, which is 93 plus A. 2 times 120 would give me 240, equals 93 plus A, minus 93, minus 93. So A is 147. Okay. Let's see, looking at B, that's kind of difficult to do right now, but because if I look at B, I need to know A and C. So B is going to be, again, that 2 times my angle. So 2 times C is going to equal A plus B. And unfortunately, I don't know A or B yet, so I can't really break that one apart just yet. Well, actually, I can. Because remember, a fancy little rule says that my angles in a quadrilateral that are opposite have to be supplementary. Let's see, opposite quadrilateral angles are supplementary. So C plus 95 has to equal 180. Therefore, C would be 85, because I can just subtract 95 from each side. And the same logic would apply to D plus 120, so D plus 120 equals 180, so D is 60. And then knowing that C is 85, I get 2 times 85 equals A, which is 147. Plus B, 2 times 85 would be, what, 170? Okay, equals 147 plus B, subtract 147 from each side. So B is 23 degrees. Okay. So we have 4 different problems in there. But as long as we can kind of figure out some way to work somewhere, we can kind of break it down. The biggest thing is to look at my angle and see what it's actually intercepting. So again, because my 120 starts here and branches off here and here, we connect those joints together. Or just like how C broke off and got the A plus B. So I get, let's see, 93, this is the center. I get A, B, and C. Okay, so again, now we just need to use some of our rules. Well, looking at A is pretty cut and dry. A's arc would just be right here. So 2 times angle equals my arc, and if my angle is A, well 2 times A has to equal 93, divide by 2, divide by 2, 93 divided by 2, let's see, 90. So A equals 46.5 degrees. These a little trickier, but if we just think about it for a second, and one of our theorems kind of tells us the answer. So B intercepts a semicircle. And a semicircle is half of a circle, well the whole circle is 360, half the circle has to be 180, so B has to be half of that. 2B equals 180, divided by 2, divided by 2, B has to equal 90 degrees. And then C is trying to be tricky, but it's not real. If this is 180, this is 93, what has to be left? Well, 360 plus equals is the entire circle. 180 and 93 are 2 sections. And all that's left is that C. So 180 plus 93 gives us 273 plus C equals 360. And I can just subtract 273 from each side. So C equals 87 degrees. And that's it for 12-3. 12-3 is all about, again, those inscribed angles and the opposite corresponding arcs. So on to 12-4. Which is angle measures and segment lengths. Okay. So, something like this, I have 85 degrees and 45 degrees. Those are just for these corresponding arcs. I have 10, which is just this segment length. 10 is just here to here. 8 is just here to here. I have 9 from here to here. And then I have x, which is this last one. Okay. So again, these are all theorems. So first with x, if my circles intersect on the inside, their products have to be the same, or my lines intersect on the inside. So I get 10 times x, because they're part of the same line segment, has to equal 9 times 8, because they're part of the same line segment. Well, 9 times 8 would be 72, so I get 10x equals 72. How do I get x by itself? Well, I would just divide by 10. So x equals 7.2. Now y is a little trickier, because y is actually this interior angle. Now whenever the angles intersect or are on the inside, they are the average of the sum of the corresponding arcs formed by those lines. So y equals 1/2 of the 85 plus 45 because it's on the inside. Remember, it'd be half on the inside. I think we'll have an example where it's on the outside. We do have an example on the outside. So inside, sum. So 85 plus 45 is 130. And then we get half of 130. So y equals 65 degrees. Be a good thing to review those theorems. So again, for angles on the inside is half the sum. Outside is half the difference. Lines on the inside, they have equal products. And when lines are on the outside, you take the outside part, outside times the whole. So remember we did something like this. If I had where this part was x and this whole thing was 7, and this part right here was y, and this whole thing was 8. Let's make it 8. We would get x times the entire thing, so 7, equals y times the entire thing, so 8y, for example, something like that. So let's say we have something like this, z on the inside. We'll say that this is 45 degrees and this is 139. Okay. So again, my intersection of the lines occurs on the outside, so it's going to be, the z is going to be half the difference, where I get 139 minus 45. 139 minus 45, so 139, 45, 4, 94, so then I get 1/2 of 94. 47. So z equals 47 degrees. I'm going to use the same drawing just because I'm lazy. But you're going to probably want a new one here. So you're going to want to probably redraw this. And then we're going to have, let's see, 11 for this part. This is 18. 18. This part's going to be 12, and this part's going to be C. We're going to solve for C. Now again, our intersection occurs outside the circle, so we get the outside part, which is 11, times the entire segment. Well, the entire segment isn't 11 or 18, it's 11 plus 18. So I get 11 times 29. On the other side, I'm going to get 12 times the quantity, 12 plus C. Well, I can't just do that, so I'm going to have to just distribute. So I get 12 times 12, which is 144, plus 12 times C, so 12C. And then I get 11 times 29, which is 319. So I get 319 equals 144 plus 12C. Now here I can just do some algebra and try to solve for my C. So minus 144, minus 144, 175 equals 12C. And then of course I would just divide by 12. Divide by 12. C equals roughly 14.6. Again, outside the circle, so we take our outside part times the entire segment. Okay, and that actually does it for 12-4. So we get to 12-5, which is circle coordinates. And this entire section can be summed up by that one formula we had for circles. X minus h squared plus y minus k squared equals r squared, where h comma k is our center. So if I give you the center, say I told you 0, 0 is my center, and r equals 3, could you write me an equation? Well, you could. You could just say x minus 0 squared plus y minus 0 squared equals r squared, so 3 times 3, so 9. Because again, h comma k. Now, if I gave you the equation, could you then find me a center and a radius? So let's say we said something like x minus 5 squared plus y squared equals 4. Okay, well again, remember radius is just this, but this is squared, so I have to take my number and do the square root of it, so r actually equals 2. For my center, I need to figure out h and k. Well, it should be x minus h, so my h is actually just 5. Now the goofy thing here is our y doesn't have a minus anything in there. We've talked about that way back when we did 12-5. If it doesn't have one, that's the same thing as saying y minus 0 squared. So my k would actually just be 0. So my center would be 5, 0 in this case. And the trickiest one is, what if I give you a center and a point on the edge of the circle? So something like, if my center was 5, -2, and it passes through point, the circle passes through point -4, 1. Well, again, if I had the circle, if I just had a circle, and I have a center, and I have something on the edge of the circle, to find my radius, I just need to find the distance between those. So if I'm given 2 points, I can just use the distance formula. So, remember, distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So, I get, let's see, labels of points, x1, y1, x2, y2. Again, it doesn't matter which one's 1 and 2 as long as the 1's are together and the 2's are together. So I get -4 minus 5 squared plus 1 minus -2 squared. -4 minus 5 would be -9. -9 squared would be 81. 1 minus -2 would be 3. 3 squared would be 9. 81 plus 9 would give me 90. And against a square root, so my r equals the square root of 90. And I actually already have my center. So my h is 5, my k is -2 because the center is already given. So now I just need to plug it right into my formula of x minus h squared plus y minus k squared equals my r squared. So just plug those values in. X minus 5 squared plus y minus a -2, so plus 2 squared equals my -90 squared. Now the thing is, if I take a square root and I square it, they just undo each other. So my final answer, x minus 5 squared plus y plus 2 squared equals 90. Then I get to 12-6, which again is all about locus. So, let's see. Let's say I have two rules. Oh no, this one just says a one rule. Remember, locus just means I need to just follow some rules. So what if I said 6 centimeters from point X? Well, first I'm going to need a point X. And I need to start visualizing what 6 centimeters away from point X would look like. So, if I had a ruler and I know 6 centimeters away, this would be a point away from X. This would be a point away from X. This would be 6 centimeters away from X. 6, 6, 6, etc. If I'm 6 centimeters away from point X, I would just have, my locus would just be a circle with a radius of 6 centimeters. Okay. Again, I would encourage you to do the review problems on your own assignment at Math Excel. They're all questions like this one in like the same order, so you can go through each individual one and just see how I went about doing this, how you can go about attack these problems, and I hope it all makes sense. If you have any questions, feel free to let me know. Thank you.